Hi, and welcome to this end-to-end Azure Data Engineering project video. Did you know hospitals generate thousands of patient records every day, and most of that data is unusable unless it is properly ingested and transformed? In this video, I will show you how we can convert raw hospital encounter logs into cleaner, actionable insights using Azure Data Factory, Data Flows, SQL Database, and data lake storage. We will go through ingestion, transformation, storage, and reporting, everything that you need to successfully build a healthcare data pipeline. So let's jump in. Okay, so let's get started. Before we dive into Azure or looking at the data or doing anything else, I want to emphasize on two very important points. Now, you must have heard a lot what a data engineer does. You must have heard that data engineers moves data from point A to point B. You must have heard about ETL, which is extract, transform, load, and that's exactly what a data engineer does. But the point that I want to emphasize over here is that a data engineer must build pipelines or move that data from point A to point B to serve the business. And that could be increasing revenue, generating sales, optimizing processes, anything of that sort. A data engineer should always keep that in the back of his mind before creating or building any pipelines. And the second thing that a data engineer must ensure is that they are making their data analysts' lives easier. So call it a preamble or call it anything else, but that's what a data engineer should always try to do. Now that we understand what a data engineer does, we're gonna start with understanding the data engineering process. And the way we're gonna do it, we're gonna first imagine a world wherein there are no computers, there's no cloud. So we're gonna see at the very basic level what data engineering is, and we will understand that by looking at an example of a grocery store. It's a fictional grocery store. So we're going to go through the steps or the processes that are involved in the data engineering process. So every evening, the manager of Greenleaf Grocery sits down with a pile of logbooks. So he just maintains logbooks and one shows like what was sold that day, so it shows them the sales for that day. The another list deliveries from suppliers, so this is what are the things that he's getting for his store. And the third holds notes from customers. There could be other logbooks as well, but we're just going with these. And of course, like, it has all the events that happen throughout the day, like, every time a customer purchases something or he gets a delivery. So all of that is noted down, and on which date, on which how much quantity he gets. So all of that is being noted down. And the manager obviously wants to, again, if we go back to this, he wants to increase the revenue, he wants to optimize his processes, and therefore he does need to look into those logbooks more deeply. And that's where this data engineering comes in. So as I mentioned previously about extract, transform, load, the data ingestion will involve 4 steps. We are going to look at 4 steps over here. After load, we also have to do reporting. But the first step is the ingestion. So all of those logbooks, which has all those receipts, those numbers, all of that different kind of data, and that data might be segregated by different sections like fruits, dairy, bakery, suppliers. All of that data needs to be first collated in one single place, and that process is the ingestion. So as it says in the data world, this is called ingestion, bringing data from many sources into one place. Then the next step is going to be transformation. We need to clean and organize that data, because some in some places you might have like the word tomato written in different ways. Sometimes there would be some missing data. Sometimes the cost or the numbers might be inconsistent. So we have to all check all of those things, fix errors, make it consistent, and then once it's all cleaned up, we need to store it as transformed or processed data. So, as it says, the transformation is turning this raw, messy data into clean, usable information. Once we are done with uh, our transformation, we need to now store it in some place uh, wherein this data can finally be used for reporting purposes. So putting things where they belong. Once everything is neat, the manager files it away carefully. One binder for sales, for suppliers, for feedback, and like in model time, this is like storing data in a database or data warehouse, so it's safe and easy to search. This is also the data which data scientists work on. So once we have done all the transformations, once we have done all of this cleaning, we need to store it in some place. We can call it like a storage layer, and this is the storage layer which your reporting tools like Tableau or Power BI will connect to, and that's our next step. Like, we're going to do some reporting. We will do this in this project video as well. We're going to learn from the data. The manager opens a summary sheet, so how many apples he sold during the week, during the day, or during a month. So we might store some sort of aggregated data as well, or report on aggregated data. And this is why this reporting layer, or these graphs or dashboards are going to help us understand which is our most popular product. So we should order bread some more. If there has been delay from supplier, we need to find a new or faster supplier. So things like that. This will help us make those decisions that will again, I'll again keep going back to build pipelines that serve the business. So increase revenue, generate sales, optimize processes, things like that. Okay, so I hope now you have some understanding of what steps are involved in data engineering process, and more importantly, why we are doing it this way. So with that understanding, let's move on. For this project video, I am assuming that you do not have any knowledge about Azure or cloud, although some knowledge would be beneficial. It's not necessary. I'm hoping you know some SQL, because we'll be using window transformation in one of the steps, and towards the end we'll be copying the data in SQL database. But even if you still don't, that's okay. We'll be learning it in this project video. And then finally, you need an Azure account, since this project is on since this is Azure Data Engineering project. So we need an Azure account, and we will be creating one in this video. Now let's look at the tools or the resources that we'll be using in this project video. In this order, we have first Azure Data Factory. As I mentioned previously, the first process is ingestion, getting the data from those multiple sources into one place. We will be using Azure Data Factory for ingestion and bringing them into Azure Data Lake Storage Gen 2. So that's where we'll be storing our raw data. Once after that, we will do some transformations using Azure Data Flow. Once those transformations are done, we're going to run our pipeline again using Azure Data Factory and store it in a transform layer, once again in Azure Data Lake Storage Gen 2. Finally, we're going to copy this transform layer data into a SQL database, which we will then connect to Power BI for our reporting, getting those insights, and helping stakeholders make decisions. And this is what our solution architecture as well looks like. We get the data from the internet via HTTP connector. We use Azure Data Factory for the ingestion. The ingested data first is stored in ADLS Gen 2. We use data flows, Azure Data Flows for the transformation. We run the pipeline and then store it in a transform data layer in ADLS Gen 2 again, which we then copy to Azure SQL Database, and then we use Power BI for our reporting purposes. The next step involved in this data engineering project is going to be understanding our data. So we're going to start with that. So let's look at the patient's data file that we have. Also, all of the data is available at this link. I will leave this link in the description, as well as we will be using this link when we start doing the ingestion. So now let's look at all of the data that's available, or the one that we will be working with. First, we have the patient's file. Let's look at the columns that are available in the patient's file. So we have the ID, which is a unique identifier for the patient. We have their birth date. We have their death date, if in the case they pass away. Then we have their prefix, their first and last names, their suffix, maiden name, their marital status, whether they are married or single, their race, white, black, Hispanic, things like that, ethnicity, their gender, whether they are male or female. Then we also have some other information, which is like their birthplace, address, city, state, which county they are from, then their zip code, and finally latitude and longitude. So this is all the information that we have available for the patient file. Let's now look at the payers data. So for payers, we have, this is a short file. So we have the unique identifier for each payer. Then what's the name? So this is basically their insurance, dual eligible, Medicare, Medicaid. So where which insurance is covering those patients that we saw in the previous file. Then this is the address for that, for their office, city, then state headquarters, zip code, phone number, things like that. Let's look at the next data file, which is encounters. Now, what encounters has is every single encounter for the last 10 to 11 years of the patients that visited the Massachusetts hospital. That's what is available in this file. Now, of course, one patient might revisit the hospital for the same illness or for a different reason. But yeah, that is what is in the encounter file. So once again, we have the ID, we have the start, when they arrived at the hospital, stop, when they left, and we have both start and stop until the second. So we have the entire date, and then hours, minutes, and seconds. We have the patient file. Of course, these values can be repeated because one patient might visit the hospital more than once. The organization, this is just one value. It's the Massachusetts hospital, so this value doesn't change, and therefore this column is sort of redundant for our project. Then payer, who was the payer for that patient, which is again the same insurance, which insurance that they use. Encounter class, what was or the reason for their visit, or how did they come? So ambulatory, outpatient, wellness, urgent care. So there are about 6 different encounter class. Then the code. So what was the reason for them? So we have a code and description for that encounter, and what procedure was performed in that encounter. And then we have the base encounter cost, the total claim cost, like the payer coverage, how much did the insurance pay, and then the reason code and reason description for that patient's visit or encounter. And then finally, we have the procedures file. So in procedures, what we have is for each and every encounter, what are all the procedures that were done. So once again, we're gonna have a start and a stop, like, if someone came to the hospital, so what all the procedures were performed, and, like, what was the start and stop time for that particular procedure. Once again, we have the patient file. The values will be duplicated because even in a single encounter, a patient might get different things done, like they might go for an x-ray, they might have a consultation, they might have some sort of other blood test, things like that. Whatever things were performed to the patient in that particular encounter, that will be there. Once again, encounter will also have duplicated values because, like I mentioned previously, different procedures can be performed during a single encounter. So what exactly was performed is in the code and description column. Once again, we have base cost, and we have the reason code and the reason description, why a particular procedure was performed. Hopefully that gives you an understanding of the data that we will be working with. And now, before any further ado, we can get started with setting up our environment. So for environment, we need an Azure subscription, which we're gonna sign up now. We need Data Factory, Data Lake Storage Gen 2, and Azure SQL Database. These are the resources that we will be creating once we have signed up for Azure. To sign up for Azure, we will start with going to portal.azure.com. This will bring up this page. You would need to provide your email address. If you don't have one, you can create a Microsoft email address by clicking on this. But since I have one, I'm gonna just sign up with my email address. It will ask you to enter your password. And once you're here, you will see a screen like this. I only have a Azure account. I still don't have a subscription. So if you have never used Azure subscription before, you can start by clicking on this. If you're a student, you probably might be able to use this one. So you can start this. So you can click on this. So let's see what's under over here. Since I have already used my Azure subscription, I won't be able to use this option, but let's see what's in there. So try Azure for free. We click on this, and this will bring up an Azure subscription sign up page. And there are some 3 steps that you will have to perform. You'll have to give your country, your address, your card, debit or credit card numbers. You'll have to do this authentication to prove that you are human. So I won't be able to do this, so I'm gonna go back and I'm gonna click on pay as you go. I have 4 steps, so the steps are more or less similar, but let's sign up. I'm gonna enter my personal details, and once we are done, I'll see you towards the end. On the second page, you're prompted to give your address. So let's input that. Here you're being prompted for your card numbers, the expiration date and the CVV. So let's input that. On the final page, it will ask if you want to sign up for any kind of support. I'm not signing up for any technical support, and neither should you, because for this basic project, we don't need it. So we're just gonna click on no technical support, and let's click on sign up. Once the sign up process is complete, you will be directed to a page like this. Let's have a quick overview of what are the options that are available on this page. There is a quick start center which can tell you a lot about navigating this portal, and I would recommend that you should check this out in your own time. But for now, we're going to go to home. We can click on this plus button to create a resource. So resources like those Azure Data Factory, Azure SQL Database, ADLS Gen 2, which we'll be creating today, can be done via this button. And there are all of these other options. So these are all the resources which we can create. So some sort of shortcuts. Once those resources are created, they will all appear over here under these resources section. You can also mark some of them as favorite. Then below you have the subscription which we have signed up for. You might have signed up for a student or a trial. For me, it's the pay as you go subscription. And then over here we have again all of these different options. We can create different dashboards to again as shortcut for our services, and a lot of these services that we can create are available over here. One of the very important ones as well is this cost management and billing. You should keep an eye on this. It will give you an idea about the money that you're spending. Right now there's nothing over here since it's a new account and we haven't created any resources. So let's start doing that. We can start with creating these three resources next, which is Data Factory, Data Lake Storage Gen 2, and Azure SQL Database. So let's start. We'll click on create a resource. Let's search for Data Factory. Okay, we click on this, we click on create. We have the Azure subscription one already selected. That's the only subscription that I have. We will need a new resource group. So a resource group is where all of your resources that we're going to create in this project will be stored. This helps us in managing the resource, like they're all under one umbrella. We can check how much we are spending on the resources or under the resources under this resource group, and later on it can also help us with cleaning. So let's click that. We give it a meaningful name, RG for resource group, and hospital patient, since that's what our data is about. We'll give it a name, ADF hospital patient. This name needs to be unique, and let's see if it's available. If not, we can just add some numbers towards the end. Let's go ahead with the region. Pick the region that's closest to your geographical region. Also be mindful that Azure Data Factory is not available in all the regions. So choose Canada Central if you are unsure. We can go with the version v2. Next, click on next. We can configure get later, click next. All of these default options are good enough. So yeah, let's click on next, and it's gonna do a review, and once it's done, we can click on create, and now it's doing the deployment. So we will come back to the video once the deployment is complete. Okay, so the deployment is complete. We can click on go to resource, and we have the resource over here. We will look more into this after we have created the other two. So let's move on and first create the other two resources as well, beginning with Data Lake Storage Gen 2. So once again, we click on create a new resource. Let's look for storage account. So ADLS Gen 2 is built on top of the normal storage account, which is the blob storage. So, but it gives some additional features like hierarchical namespace, and it manages workload, analytics workload or big data workloads better. That's why we're going to create that. So let's pick a name again. Let's call it DL hospital patient, DL for data lake. Canada Central, the resource group is already selected. We can go with standard. We don't want the geo redundant storage as we don't want any backups across different geographical regions. We can click on next. All the other default options are good. The only thing that we need to enable over here is this enable hierarchical namespace. So let's click on that, and this will enable Data Lake Storage Gen 2. Let's click on next. Yes, all of these options are good. Click on next. Next. And it will validate. We can just click on review and create. It will validate, and once the validation is done, we just click on create. Okay, so the deployment is in progress. We will come back to the video once the deployment is complete. So the deployment is complete. We can click on go to resource and check it out. Over here, you will see the data lake storage, and it has all these, the properties that we just put in there. So, and let's look at some of these options as well. On the left, we have access control. So when there are multiple people trying to access your data lake storage, you would need to give them access through over here. In this case, since it's just us, we don't need to do that. Containers is where we will be creating the folders or the containers, and we'll come back to it very soon to store those raw and transform data. There are other options as well that you might want to take a look at and explore in your free time, and I would highly encourage you to do that. Okay, let's create our final resource, which is the SQL database. We go on the top left, create a resource. Let's look for SQL database. Here it is. Let's create this database. Again, we have the resource group. Let's select the resource group, the database name. So let's give it a meaningful name, which is DB hospital patient, and this name needs to be unique as well. Okay. Let's create a server for our database. SRV hospital patient. Okay. Yep. Let's choose the location, same as before. And we could again use, once again, Microsoft Entra or both SQL and Microsoft Entra authentication. But since it's going to be just one person accessing this, we can go ahead with the SQL authentication. Let's pick a username and password and then come back to it. Once you have selected a server name, an admin name and a password for your database server, let's click on OK. And we want it to be development, as this would be less expensive and production is unsuitable for this project. We don't want to use Elastic Pool. Let's click on this configure database. Once again, we can go with the basic, as this is a very basic simple project. We need we get 2 gigs of data. This will be the cost per month, and in your local currency this might look something else, but this is good enough for us. Later on, even if you wanted to change it, you can. So, but for now we're just going to go with basic. Let's click on apply. Once again, we don't want storage redundancy. We're just going to go with locally redundant. Let's click on networking. So since we will be connecting it via public endpoints, let's choose that. And we will also use other resources, other Azure resources to connect to this database. So let's select yes on both of these options. And then after that, I think all the default options are good enough. We don't need to change anything. Let's click on review and create. It's going to do a validation, and let's click create. It will take about two to 3 minutes to deploy. So once the deployment is done, we can come back to the video. So our deployment is complete. We can click on go to resource to check this resource, and it has all of the similar things as you have seen for the previous resources. It has the basic. This is our server name, no elastic pool as selected, and it's in the resource group hospital patient. Now let's go to home and let's make sure under the resource group hospital patient that we have created all the resources that we needed. And you will see, yep, we have the data factory, we have the server for the database, we have the actual database, and then we have the ADLS Gen 2 account. Now we are ready to start our data engineering steps, and the first step is the ingestion. Before we do that, let's do some housekeeping because I want to keep this a little bit clean, and in industry as well, you might have to do this, so let's start with going to this ADLS Gen 2 account. And if you remember, I mentioned that I will be storing the data first as raw, and then we will do some transformations, and then we'll also store the transform data in here. So for those two things, I will just create 2 containers over here. You click on containers and let's give it raw. Let's click create. And then the next container when the data is processed. Okay, so we have created the containers. Let's go to the data factory and let's click on this launch studio. So data factory is loading, and this is what the home screen is going to look like for you. We have the options for ingest, orchestrate, transform data, and these are also the options over here as well. So we have the home. Author is where we would be creating all those pipelines, the data sets, the data flows for the transformation. Monitor is the screen where we will be monitoring our pipeline runs, our trigger runs, and manage is again a lot of these things, like the linked service, which will be create and we'll get to in a minute, the Git configuration, the triggers, all these things you can manage through this window. So let's minimize it. Now, before we start with the ingestion process, now let's see what Azure needs or how we do this in for Azure. So let's look at this. So we have 4 files. Patients, payers, encounters, and procedures. They are in a source, in an internet source, and we will be putting them in the ADLS Gen 2 account, and eventually once the transformation is done, we'll be putting them in the Azure SQL database. Now, in order for Azure Data Factory to communicate with all of these resources, it needs something called a linked service. Call it a communication channel, a telephone line, if you want to call it that way. So it needs these channels to communicate with all of these different sources. So if you can see, we need three of these channels. One which speaks with HTTP, which is GitHub in our case, the other one which speaks with ADLS Gen 2, and then the third one which speaks with SQL database. So we will have to create these linked service for them. Along with that, we will also need to create source and sink dataset. So whenever the data is being moved or transformed from one place to another, so let's just say from source to the ADLS Gen 2 raw folder, we would need four sources, which is for four files, pairs, encounters, patients, and procedures. And then in the raw folder, we would need four sync for all of those four files. Once it is being done, once it has been transformed, we would again need four sync data sets for the transformed. And once it's done, we would then need it for SQL. So these are the things that we would need to create and call it housekeeping. So we'll first create these as well, and some others we will create later on as we progress through this project. So I'll start with first creating the three linked service, for one for HTTP, one for ADLS, and the one for SQL. And I'll start with creating the eight of these data sets, for source and for sync. Once we get there, it will become more clearer. So let's start with that. Let's start with our linked service. So for linked service, we go under this manage, we click on new over here, and since the first one will speak with HTTP, so let's call it that. Let's click on continue. Let's give it a meaningful name, ls HTTP, and in our case it will be speaking with GitHub. So this is where all of our data is. I will also leave this link in the description. So GitHub, and we can give it some description as well. Our URL, base URL is going to be https github.com. Since we won't be logging into this, so we can choose anonymous, and we can test our connection. The test is successful, so let's click create. So this we have created. Let's create for the ADLS. Let's go into Azure Data Lake Storage Gen 2. Let's click continue. Again, I want to call it ls for link service, ADLS, and then give it a proper name. So the name of our is DL hospital patient. So let's call it that, DL hospital patient. Description, we can give some meaningful description, and storage account name, which we will be creating to. Let's test the connection again. The connection is successful. Let's click create. And finally, let's create one for our SQL database as well. Let's click on Azure SQL Database, just this one. Let's give it a meaningful name, ls underscore. So since this is for database, so SQL DB, and let's give it the name, which is DB hospital patient 5055. So DB hospital patient 5055. 2.0 Azure subscription. Let's select our subscription. the server name. We need to select our server name, the database name, and we'll also choose the admin name and the password. So it's the SQL authentication. So let's input that as well. Once you have put in the password, let's test the connection. And the connection is successful. So let's click on create. And we have all our 3 linked service created now. Let's do publish. We can publish all of them. Once the publishing is complete, as I was mentioning, or let's again go back to this picture, we would need source and sink data sets. So let's create that. So we would need 4 source data sets since the data is coming from HTTP or GitHub, and we would need 4 sink data sets as the data is coming into the raw folder of the ADLS Gen 2. So let's do that. Okay, so let's go into the author tab. Let's start with creating our data sets. Also, since we would be creating a lot of these data sets and I like to keep things clean, again, I'm gonna create some folders first. So the first folder we can call as source, and one more folder we can call as raw, and another one for the processed, which will happen after the transformations. Okay, so let's start with creating the data sets under the source. So we can do new data set. Let's call it HTTP. Let's click on continue. Since we know our files are CSV, it will be this one, CSV. Let's click continue. Let's give it a meaningful name. We'll call it DS for data set. And the data is coming from HTTP. Our first file is procedures. Let's just say. So we'll need to create 4 for all of them. Linked service, we already know it's this one. We have header in our data set, as we have seen already. Relative URL. So if we go back to our data set now, excuse me, our data sets over here, we have all these procedures, payers, patients, and encounters. So we would need their relative URL. So let's just do copy link. This will give us the entire URL, and we'll just edit it to so that it's just the URL for procedures. So we'll have to again change this blob as well to raw. First row as header. There is no schema. Let's click on OK. And we have created so we have comma. So the column delimiter is comma. Rest everything looks good. So we have this. Let's quickly create the other 3 as well. And I would also recommend to pause the video over here and do it yourself. Okay, let's do it. New data set, same HTTP. Let's click on continue. CSV, continue. Give it a meaningful name, DS HTTP. Let's do encounters this time. CSV, link service, first row is header. Let's go and find our data set, copy link. Let's just give the relative URL. So let's do that. Click OK. And once again, comma is fine. Let's create 2 more. New data set, HTTP. Click continue. CSV, ds underscore http patients. Let's find our URL. Let's click OK. And let's click create our final as well. Final source. We would then need the sync ones. CSV. Let's call it ds http. I think pairs is the final one. The file is called pairs. Yep. Copy link. Pairs CSV. Click OK. And yeah, so these are 4 that are created. Let's now also create under the raw, which will be the sync. So let's create new data set, all of the same. So we will, this time instead of HTTP, we will select ADLS Gen 2. Let's click on continue, and the file again is going to be CSV. So let's click on that. And let's give it a meaningful name, ds raw procedures CSV. We know what the link service is. We have already created that. And we will be saving it under the raw folder. So let's call it raw. Click OK. And we'll be just saving it as one file. So let's call it just procedures.csv. First row is header. Can't import schema as there's nothing yet. Click OK. Let's create the other 3 as well. And once again, I would recommend pausing the video and doing this step on your own. Okay, so new data set, ADLS Gen 2, CSV. Let's call this one DS dataset, raw encounters, CSV. We store it under the raw folder. Click OK. Let's give it a name, encounters.csv, and click OK. Next data set is going to be ADLS Gen 2. Click continue, CSV, ds underscore raw patients CSV. Let's click on raw patients.csv. Can't put schema. And the final data set, which is going to be ADLS Gen 2 CSV ds underscore raw pairs CSV and pairs dot CSV. Let's click on OK. Sorry, we can't import the schemas. There's nothing there yet. Okay, so all of these source Let's go back to the slide again. So our link service have been created, our source and sync datasets have been created, and now all we need to do is create a pipeline to copy the data from the source to the sync. So again, let's do that. And before we do that, let's click on publish all. And while it's publishing, again, I know we'll be creating multiple pipelines today and I want to keep it clean. So I'll create some folders. So let's create folders, which is ingest first of all, and then later on when we'll do transformation. So let's create for that transform, and let's click create. Okay. So our resources have been published, or our data sets. So let's click on ingest, create a new pipeline. We need copy data activity for this. It's available under move and transform, or you could even just look for it. So we bring copy data. Let's give it a meaningful name, which is copy procedures data. Let's click on source. So let's also look at some of the options. Again, we're going to give it some meaningful description. Timeout is how much time it should try before giving out, so that's what maximum amount of time an activity can run. So we probably don't want it to run for 12 hours or try for 12 hours. So these are the things. Again, once you are in the production scenario, there are these things that you would like to change: how many times it should retry, after how many seconds it should retry. So these are some of the options that are available. So let's give this as a meaningful name as well, PL ingest, since we are doing procedures. So let's call it that. Next, let's choose the source. So we know our source is procedures HTTP. Request method is get, and yeah, everything else can remain the same. We don't need to skip any line count. So let's go ahead and sync. We would select DS raw procedures, and all of the other options just can remain as default. Mapping we don't need to do. The settings is default settings are fine, and we can just click on debug, and this should copy the data, and we'll then check once it has been done. So the pipeline has been queued, and now it's going to run the pipeline. It will take a few seconds. Sometimes it might take a minute or two. We can click on this refresh button to check where we are at. So it has 11 seconds has passed. We'll just wait for it to finish, and then we'll come back to the video. Okay, so it has finished in 13 seconds. Let's click on this. Let's click on details. So one of the files has been written. So now let's see. Let's look at our data. It should be over here, and we can go in this containers raw. So as you can see, the procedures.csv file is available in the raw folder, but we won't be able to preview it here. And for that, I prefer Azure Storage Explorer. You can go to this URL and download it. It's available for both Windows and Mac. I already have it downloaded. So let's open it, and you can click on this icon, and you can add your account from over here. And once it's done, you can come over here and we'll see this Azure subscription, my email. We can open it. We have the storage accounts. I only have one storage account, which is the DL hospital patient. If I had multiple, all of them would show here. In underneath, I have the blob containers, which is the same as blob containers, file shares, queues, and tables. So if I go back to my previous screen, which is this one, so if I so it's these same options: containers, file shares, queues, and tables. That's again available in the Azure Storage Explorer. I can go to the folder raw, and I have the procedures.csv file, and we can preview it over here. And as you can see, we have the start, the stop column, the patient ID column, the encounter code or the encounter ID, code description, cost, reason, and reason description. So we have all the columns and they came in properly as well. So we have successfully ingested our first file, and now we need to ingest the other three files. Once again, I would recommend you to pause the video here and do it on your own. If not, you can always come back to the video. So I'm gonna now ingest the other three files, which is patients, encounters, and payers. So let's do that. New pipeline. Let's give it a name, PL ingest. Let's do patients next. We need to copy data. Let's give it a meaningful name, copy patients data. Let's go to the sink. Our sink is going to be HTTP patients, and our sink is going to be raw patients. Okay, we can keep all of the other options. This is good enough. Let's do a debug. Okay, the pipeline is running. Let's wait for it to finish, and then we'll come back to it. Okay, so our patient's data file has also been copied. Let's check the details. Yeah, looks fine. Everything looks fine over here. Let's go and check in the Azure Storage Explorer. We will click on the refresh button over here, and we see patients as well. Let's click on that and let's check its preview. Yeah, patient ID, birth date, death date, prefix, and all of the columns as expected. Yeah, so this worked successfully too. Let's do the next two now. Let's click on new pipeline, PL ingest. Let's do encounters next. Copy data, so we're gonna copy encounters data. Source is going to be the HTTP encounters. The sink is going to be the raw encounters. And yes, let's click on debug. Okay, and the pipeline has started. Okay, so this time it took 14 seconds. Let's go and check. Let's click on refresh. We have the encounters as well. Let's preview. Yeah, looks like the ID, start, stop, patient, organization, pair, encounter class, and all of the data did come through. Okay, so we're good. Let's ingest our final file, which is pairs now. So let's give it a meaningful name, PL ingest pairs. We need to copy the data. Our source is going to be raw pairs, and our source is going to be HTTP pairs, and our sink is going to be raw pairs. Okay, let's click on debug. The pipeline has been queued and it's gonna start. Okay, it's started. And once it's complete, we'll come back to it. Okay, the pairs data has been copied as well. The pipeline took about 12 seconds. Let's go ahead and check in the Azure Storage Explorer. Yep, we have the pairs. Let's preview. And yeah, it was a small file. We have all the columns that we were expecting, and they're all there. Okay, so our ingestion process has been successfully completed. We can click on publish all, and it's going to publish. Now, if you can recall, our next step was transformation, and we're going to get to that in a minute. But before we do that, let's again go back to the first slide that I showed you, which is a data engineer should be building pipelines to which help with the revenue, increase the revenue, optimize the processes, make data analyst lives easier, all that stuff. So that is our end goal here. So now we can start with the transformation, but essentially we can't do much unless we don't know what the stakeholder or the data analyst is trying to accomplish. So to help us with that, we have been provided some questions for what the data analyst might be doing or what the stakeholders might be interested in the data in these 4 files. So what we're going to do next is we're going to look at some of these questions, and then we're going to think about how these questions drive our transformations process. So let's check it out one by one. So how many total encounters occurred each year? We have the encounters file. We have let's preview. So we have the encounters file, we have the encounter ID, we have the start and stop date. I don't see, and from the start and stop, we can take out the year, we can calculate year, which the data analyst can easily do. So I don't think we need a new column with just the year information. But if you want, you could actually separate it out into year, month, date, and then time as well. But I'm not going to do this because I think that's easier to do in Power BI, and we probably do that over there. For each year, what percentage of all encounters belong to each encounter class? So we have the encounter class column, and we have also the code. So we can do a count over here, and then from the count, percentage should be easy. Again, I don't think we should be doing this for the data analyst. And what percentage of encounters were over 24 hours versus under 24 hours. Again, so we have the start and stop column. So what that means is the data analyst again can calculate which encounters were over and which were under, but I think we should be including a column for that, because we have each encounter as unique. We can include a column which is like a flag whether the encounter was under 24 hours or over 24 hours. So we can add an additional column for that, and that's what we're going to do. So, and we're going to come back to all of the, I have proper slides for all of the transformations that we're going to do, but we're just going through these questions to help you think how we should be changing or how we should be doing the transformations on these files so that it serves the business and it makes the data analyst's life easier. So let's look at a few more questions. Let's move on to the next slide. Okay, so how many encounters had zero pair coverage and what percentage of total encounters does this represent? So once again, let's go back to the encounters. So we have the pair coverage and we have the pair ID as well. Again, a join can be done in Power BI itself, and we don't really need to do much over here. Let's look at the slide. What are the top 10 most frequent procedures performed and the average base cost for each? What are the top 10 procedures with the highest average base cost and the total claim cost for encounters? So again, I don't see a lot. So this is the procedures file. We can preview it. I don't see a lot that we can do because all of this data is easily we can modify and can be used to plot make any graphs in Power BI, so we don't need to change a lot over here. And then let's move on to the final questions. So these are the ones that are a little bit interesting, like how many unique patients were admitted each quarter over time. So again, if we go into encounters, so we do have the patient ID, and we also have the start and stop. So from there, years and quarters can be calculated, and we can have how many of them are unique each quarter of the year. Since this is 10 years data, we will know how many unique patients come to the Massachusetts hospital. And the other two questions, how many patients were readmitted? Now this is something that I find would be difficult to calculate. Like in Power BI, you can write a DAX measure, but something that I think we should be helping out the data analyst with. So we will be creating this column, and which patients had the most readmissions. Once we create how many were readmitted, we can obviously from there on, again it's simple, which patients had the most readmissions. So that's how you should go and start thinking about what transformations you're doing, instead of just building pipelines or doing transformations and using these compute resources and which are not serving the needs of the business. So that's how we're gonna start thinking about. And now that we have some idea how we should do it, let's move on to the next slide and see which file we are transforming first. So we're going to start with the procedures file, and we are doing two transformations. We are adding a validation check, making sure that the stop is greater than start. So let's go to the procedures file. Yep, here it is. So the stop should always be greater than start. Like, the procedure when it started should happen before it stopped. So we are adding a validation check. And the other thing that we are doing is we are adding a new column, duration, showing the duration in minutes of the performed procedure. So let's just say the business user might want to see, hey, which of my procedures are taking very long to execute, or maybe I have some of the support staff or nurses who I should allocate to these procedures so that they can be performed quickly. It doesn't say that in the questions that we have, but we sort of have to think about as well. So we're gonna add one column and we're gonna add one validation check. So now we can get started with that, and let's go to our data factory. Okay, so we're back in our data factory and we can start with the transformations. We'll be using data flows, so let's do that. And the first file that we are transforming is the procedures. So let's click on new data flow. Okay, so before we start transforming procedures, if you remember, once again, we would need sync as well, because the source would this time would be these raw files, procedures, patients, encounters, and pairs. But where would I keep them once they have been transformed? So we need those sync data sets as well. So I would like to first create those as well. So let's get started with those. So we already have the folder. So under processed, let's create a new data set, which is, and it's going to be ADLS Gen 2. Click continue. We're going to do CSV files. Click continue. And let's call it DS processed or transformed. You could call it anything. We're going to do procedures. Our link service is already created. It's the same, the ADLS one. The first row will be header. We will put it in processed. Click OK. And what else we will do this time is that instead of saving it as one file, we will save it as multiple. We'll save it in a folder. Because sometimes there could be a lot of data and we might need to divide the data into different files. We might want to divide these data into files based on a column, based on pair or something, which will help with the when we are doing the data, when we are working with the data later on, that it can help on that scenarios, if we are selecting or filtering on encounter class or pair, it just helps us out later on with the filtering process. So that's why we're gonna create folders this time. So the folder is processed and the file that we have is procedures. So let's click on that. There's nothing to do and click OK. Yep, everything else looks right. Let's create the other 3 processed data sets as well, and I would recommend pausing the video and doing this on your own. So ADLS Gen 2, click next, CSV, continue, DS processed encounters. First row is header. We will put it in the processed folder, and we will, under processed, we will give it another folder which is encounters. Click OK. Let's create the last 2 data sets as well. DS underscore processed, and this is pairs. So we go it into the processed folder, click OK, and then another folder within it which is pairs, click OK, and finally we can have the patients. CSV dataset processed patients under this folder. So let's go ahead with processed, click OK, and then patients. So we have this created, and we can also do a publish all. Sorry, yeah, we won't be able to publish it just yet. So let's write the data flow or the transformation steps for our procedures, and then we will be able to take it from there. So again, df for data flow, we are doing transform procedures. Let's give it a meaningful name. So for this one, for the data flows, there are two things that we need to do. The first, we need to have a source, and in the end, we need to have a sink. So these two steps are decided, and then in the middle, we will be doing all of the different transformation activities. So let's get started. Let's add a source and let's call it procedures source. It's going to be a data set, and this time it will be the raw files. So ds raw procedures CSV. Yep, everything else looks good, so we can just leave it as it is. We can also turn on our data flow debug so that we can see how our data looks like after each transformation step. So this will spin up some Spark clusters. We just need a small and debug time. The minimum that we can select is 1 hour. So if you move away from your computer and it's idle, it will stop after 1 hour. You can't have anything less than that, and it costs some money. So if you don't want to do that, so then don't do it. But otherwise, I'll be doing it for the demo purposes. So let's click OK. It's gonna get started, and once it's done, we will come back to it. So it's starting. So as I was saying, let's go again back to the slides. We're gonna do a validation check, which is stop is greater than start. So let's go ahead and do that. Okay, so in order to check for those valid rows, we need to find an activity. Let's click on this plus icon, and the activity that we need for this one is called a conditional split. So columns or rows where the stop is not greater than start, they go into invalid rows, and the ones that are fine, they go into valid. So that's what we're gonna be doing. So let's give it a name, split check for stop after start. So stop should happen after the start. Let's do this. So we will give it a meaningful description. The incoming stream is going to be procedure source. We would do it for on the first matching condition. So the stream names are going to be valid rows, and the second one is going to be invalid rows. And let's add the condition. We can open this expression builder. Let's go ahead and find our columns. Okay, so it doesn't show any columns over here, which it should. That means let's click on cancel. I think we missed something on the last step, so let's click on cancel. Let's go and on the procedure source, let's do a data preview. Let's do a refresh. Okay, it will take some time, so let's wait. Okay, so as we can see, it has brought the data. We can see start, stop, patient, encounter, and all these values, and it's there. You will also notice that start and stop has ABC, which is like the string format, which we probably don't want. We probably want it as timestamp. So let's go back, and all of the others still look fine. What we can do is let's go back into projection. It is timestamp. What we need to do is click on, so you click on import projection, and this will show up. Let's go into, let's specify the format that we are looking for, which is this one. So let's select that. It's until hours, minutes, and seconds. And now if we go into data preview, click refresh, we'll just wait for those changes to take place. Okay, and you will now notice that those T and the letter Z is no longer here. So when we selected these timestamp or the format values, that's how it changed. Eventually, when we do it in the SQL database, when we will finally copy it in there, we will copy it in the original way, but this is just to show you over here what these time values are. And as you can see, so we also, with that import projection, these are now timestamp values. This is numbers as we expected. And now we can move on to our next step, so which is the valid rows. We were trying to ensure that the stop comes after start. So let's open expression builder, and now you can see all of those column names. So we just do stop is greater than start. Let's click on save and finish. Optimize. Okay, one more thing that I didn't mention last time. So when we are doing these debug, this optimize option, because we will be eventually copying this data, not when we run the pipeline, into a folder. So if we just use a single partition, then the files won't be like separated into, we won't be using distributed compute, which again is a disadvantage. Since it's available, the files can be moved into or split into different rows, and the transformation steps can be done, and then they can be merged at the end. So we're going to use current partitioning, which is the default. We can also do set partitioning and then ask for, like, how many partitioning we want, but we are not going to go in there. So we're just going to click on use current partitioning. Then let's click on inspect. Again, these things look right. Let's click on data preview. Let's click on refresh. And we more or less will be getting all of the rows. Okay, so as you can see, we have received all of the valid rows. We are only seeing 1000 at the moment, but we can also check for invalid rows and see if there are any. Let's see if there are. So there aren't any, but if there were, then of course the invalid rows would go into a different sink. They would be cleaned and transformed or done something to them differently, and then they would be merged with these valid rows. But fortunately, in our case, there aren't any, so we're good. So now we can move on to the next transformation step, which is adding a new column duration, showing the duration in minutes of the performed procedure. So let's do that. For this one, we need a derived column, as we are adding a new column based on that. Let's call it add duration column as the step, and we're gonna give it a name, which is duration, and let's enter the expression. We'll open the expression builder. Let's call it stop minus start, and let's click on save and finish. Optimize, we will use the current partitioning. Inspect, we have added a new column with a long, and you can see this plus means like something has been changed. In this scenario, a new column has been added. Let's go into data preview. Let's click on refresh, and let's see what this brings us. So let's look at these duration column. So this, as you can see, is like 1272 and then 4 zeros, 1023 and then 3 zeros. So this is an answer in milliseconds. What we were hoping to do is get it in minutes. So let's do that. So we're gonna go back to our derived column settings. We're gonna open our expression builder again. So stop minus start. What we're going to do is, so since it's milliseconds, let's divide it by 1000, and that will give us seconds. And since we need it in minutes, we need to divide it by 60 now, as 1 minute has 60 seconds. So this should give us something better now. And let's click on save and finish. And let's click on data preview. Let's click on refresh. So you'll also notice we started off with 9 columns and now there are 10 as we have just added 1 column. So, and we can see 212.0. So this looks better. So this is like over 3 hours, 17.05, 15.0, and then 4.51. So we have these kind of values as well, which I don't quite like, as like, this is very unclean. And again, the data analyst later on can clean it, but one of the things that I'm hoping to do is make his life easier. So what I'm gonna do is again go back into this. Let's open our expression builder and we're gonna enclose this in a round function so that we only have values up to like 2 decimal places. Let's click on save and finish. Let's go into data preview and click on refresh and we'll see it again. Okay, so the data has loaded, and as you can see that this time we have values only up to 2 decimal places, and this looks a lot more cleaner and what I was hoping to achieve. So yeah, that is done for our procedures. That was the only thing that was planned. So now what we can do is just add a sync. So we'll just type in sync. We started with 9 columns. We now have 10. Let's call it procedures sync. Add duration column is the incoming stream, and data set this time will be ds processed procedures. We don't need to skip any line count. Clear the folder. So what I would also do is check this option, since we might be running this pipeline multiple times. So I'll also check this option so that next time when I run it, I don't get an error. Default file name option, I'm going with default, but you could also choose a name of your own choice. Like if you want, if you remember, we are putting files this time into folder, and it will create 1 or 2 or 3 different files based on what it thinks is appropriate. And yeah, since we are not choosing file name options, these are not relevant for us. Output to sync. So that's all. Mapping, we're doing auto mapping. We're skipping duplicate input columns, skipping duplicate output columns. We can do optimize, the same thing. Inspect, we can check the data types over here. So start and stop is timestamp, patient is string, encounter is string, code is long, description is string, base cost is integer, reason code is long, reason description is string, and duration is double. So I think these these data types are good enough too. Let's go into preview and we will get the same thing. So let's wait for it to load. Okay, so it has loaded. We have all of the columns as expected, and we are done with the transformation of our procedures file. So we can click on the publish all button. This does not mean that the procedures processed or transformed file is going to be now in our ADLS Gen 2, because we haven't run the pipeline yet. This is just the data flow. So we will have to wait. So the data won't show up unless we run the pipeline, which we will create after we have transformed all of the 4 files or the remaining 3. So now this is also complete. And the next file that we can look at is the encounters file. Okay, so now for the encounters file, let's see what we have. So we were planning to add a new column, which is the over 24 hours, which will be a flag, basically with values 0 and 1, which shows if the encounter lasted more than 24 hours or not. We have the start and stop columns, so we can use those. The next thing that was asked in the questions that we were given is to add a new column for readmission 30 days, which is again a flag that shows which will be values 0 and 1 if the readmission occurred within 30 days. But let's have a think about one more thing. The current business requirement is we need to find out whether the readmission happens within 30 days or not. What what if 6 months from now somebody wants to know whether the readmission happens in within 90 days, or whether the readmission happens within 1 year, as we have this is like 10 years of data. So what if the business requirement change? What we will do then? So as I said previously, we want to make our data analyst life easier. So what we can do is we can add a days between readmission column, and this using this column, then even down the line, even if the data engineer is not available or he's on vacation and it's an urgent requirement, a new column for readmission within 60 days or 90 days or 6 months, whatever it is, can be added. So that's why we're going to be adding this days between readmission column as well. We will add readmission within 30 days as well, but we will also add this thing, and this is where we would also need the window function. So let's get started. So let's transform our encounters file now. So we're going to start with a new data flow. We'll call it df transform encounters. The first step is going to be the same. We select the source, which is our encounters source this time. We're going to find the source data set, which is the raw encounters, which is this one. Everything else remains the same. Projection, we can import the projection. Let's just wait for it. Okay, so we have the ID as string. The start and stop is timestamp. We can specify the format again this time, which is this one. We have the patient, organization. Yeah, all of these values, string, long, they all look fine to me. And even if something, like if you change something and you don't like it, you can always go back and then reset the schema, but we are happy with this for now. Optimize, we're going to use current partitioning. Inspect, yep, so this is fine. And then data preview, let's click on refresh. And we have the ID, the start, stop, patient, pair, code, and again it automatically picked up the right data types. The code is a long, and these look like float or real, so it's all good. Now we can add the new column over 24 hours. So let's do that. So once again, we're going to do a derived column, add over 24 hours column. And let's give it a name, which is over 24 hours. And let's open our expression builder. So this time what we need is, once again, we're going to start with stop minus start. So this will give us the time between the stop and start. But since we want it, 24 hours is basically 1 day. What we need is, since this is in milliseconds, we start with dividing it by 1,000. So now it's seconds. Now we need to multiply it by 60. Now it's minute. Now 1 minute has, 1 hour has 60 minutes. So now we're gonna again multiply it by 60 and then 24. So this is 24 hours now. And what we need around this now is an if statement. So we're gonna add if this number, which we have written, is greater than equals to 1, then the value should be 1 for saying yes, it was over 24 hours. If not, let's do it 0. And let's close the parentheses and let's click on save and finish. We can use the current partitioning. Inspect is fine. Let's do a data preview. And so as you can see, again, we have added a new column. Let's do a data preview and let's see if our values are working correctly. You will notice above as well, we started off with 14 and now we have 15 columns. Okay, so let's run it. Okay, it's done. So let's see okay, so there is 1 over here and let's check its stop and start. So it started on 7th of January 2011, ended on 8th of January 22:39:45. So this is exactly like 24 hours. That's why I used that equals to sign. If I wouldn't have used equal to, then this value would be 0 again. Let's check a few more. Let's see if this has been working correctly. Let's check a random 0. So like this one, which is 16th of January. They both started 7:37 and ended at 7:52. So very short visit. So yep, this one works too. Let's check for another one, which is this one. So 19th of January ended on 20th of January 2011, 21:16:09 and 21:16:09. So again, exactly 24 hours. And we can see that it does, the column or our transformation step does work. Okay, so now the next thing that we are trying to do is add a new column for days between readmission. Now, in order to do that, we need to do two things. We first need to sort the data, which means we need to make sure that the patient and the start column are sorted in ascending order and in that order, because for every patient, what we will then have is when was the first time they visited the Massachusetts hospital and when was the last time they did. So all of those rows will be together. Then for the next patient, when was the first time they visited and when was the last time. So we need to do that, and that's what we're going to do in the next step. So the first step is to sort. Let's find the sort transformation. Yep, here it is. Let's give it a name, sort patient and start. Okay, let's select the first one, which is patient, and we want to sort it ascending. We don't have any nulls, but if we were, we could just keep this as selected. Let's click on plus icon because the next column which we want to do is start column. So we have that. Let's do that ascending. Let's keep this again same. Optimize, inspect, and yep, so we can see what is going to happen. And let's click on data preview and let's refresh. Okay, so the data has loaded. Let's look at the patients. So the first one, apparently there's just one row, second, third. So like this is the patient. Uh, their first encounter is 18th of July 2011, and then the next one is 7th of August. So yeah, so these are in ascending order. Let's look at this patient now. So we have 20th of January, 17th of March, then the same patient 21st of April, 19th of May, 16th of June. Apparently they had a lot of visits, 28th of July. So yeah, this looks like it is in the right order. And as you can see, when the patient, so 7th of January over here, and then we again come back to then 11th of May, and then we again come back to 17th of March. So yeah, the start as well has moved around just to accommodate for the patient. So our sort as well worked. And now the next step is going to be um, we need we now need to know for each of the patient what was their last visit or encounter date. And in order to do that, we would need another column. So we're going to add a temporary column which we would delete later or not select later. So that's what we need to do. So let's get started with that. And for that, we need a window function. So what we're going to do is window, and we're going to call it get previous start, right? So we're gonna sort over every patient because we want every patient's previous start. So let's call it patient. We're gonna call it name it as patient, sort by start column, and we're gonna sort it ascending. Range would be unbounded because we want to look at the entire data set. And then the window column would be called, which we will create, we'll call it previous start, and let's enter the expression. And this is very similar to what you would write in SQL. So what we need to do is we just need to look at once the patient and the start columns have been sorted, all we need to do is look at one row above. So one row above, which is like in the past, is lag. And the column that we are looking at again is start column. And we are just looking one row. So that's one. And then if there is no row, so there should be some sort of default value. So for that, we're going to add null. And that's it. So what this is doing is the previous start is going to be a new column. It's gonna look at the start column for every patient, pick the start value like one above, and if there is none, just return null. So that's all it's gonna do. So let's again click on save and finish. And I think the patient which had too many encounters will be a good way to look at how this column works. So we're just gonna click on data preview and we will wait for the data to load. And let's go back. Okay, and we can see we have these date values. So let's look at that data who had the patient who had a lot of visits. So here's the patient. So this is the patient 0226F105. So this one. So the first time they visited on 20th of January 2011. So for this particular row, there is null because they have never visited before this, which makes sense. The next time they visit on 17th of March and their previous visit now is 20th of January 2011. So let's see if that's the case. And yeah, we can see that. Then their next visit is 17th of March. which was for this one. Then it's 21st of April, 19th of May. So if we look at this row, their previous start would be 21st of April as the value. And yeah, we can see that's the case. So we can see that it's working, and this was a temporary column. So now our next step is, if you remember, sorry, if we go back, we can add a new column if the readmission happened within 30 days, or a better idea would be to first add this column, days between readmission, and then add a flag for readmission underscore 30 days. So, and we're going to do it that way. So let's go back and add another derived column. Let's call it add between readmission, sorry, add days between readmission column. And we're gonna call it the same, days between the readmission. And I think this is also something now you should be able to do it. So I would recommend pausing the video here and writing this expression on your own. So what we're going to do is, again, start. So that's the first time they came, and then the last time that before that is the previous start column. So that's this one. So this will give us the readmission, days between readmission in milliseconds, but that's not what we want. So what we need is divide by 1000. That gives me seconds. Then by 60, that gives me a minute. Then 60, that's hours, and then 24. So that gives me days. So let's see what this looks like. Let's click on save and finish. Let's go to data preview, and we're going to click on refresh. And let's see. So again, we're getting these very ugly and big values. So let's see. Yeah, these do look nice to me. But I again want to use that round function. So I'm just going to do that. So let's go back. Let's click on open expansion builder. So this entire value up to 2 decimal places, and we can click on save and finish, and let's click on data preview, and let's check it again. Okay, so yeah, this looks better this time. And yeah, so now our next and final step is to add this new column, which is readmission 30 days. So let's do that, because now it's again very simple since we have days between readmission. So all we have to do is click derived column. So add readmission within 30 days column. We're gonna call it readmission 30 days. And as I mentioned previously, since we have added days between readmission column, we probably don't even need to add this column anymore, but we're just gonna do it. So let's do days between readmission. If this column is greater than 1, because we don't want to consider same day readmissions because that also happens, and days between readmission is less than equals to 30, and we're going to enclose that in that if block. So if that's the case, then let's make it 1, otherwise let's make it 0. And yeah, let's click save and finish. Everything else can remain the same. Let's do a data preview. Let's go back and check. And yeah, so when the readmission is 20.14, the days between readmission, we have the value as 1, 56 is 0, 35 is 0, 28 is 1, 28 is 1, 42 is 0. So yeah, seems to me that this is working. So yes, we are done with our encounters file as well. Now all we need to do is we need to select some of the columns, so we don't need the previous start column anymore. So we're going to use a select transformation. So let's do that. So let's give it a meaningful name, select columns for sync. We can skip duplicate input columns, duplicate output. Let's check if you need to rename any of the columns as well over here, you could do that, but we don't need to, so we're just gonna keep it as it is. Start, stop, patient. So previous start is the one that we're trying to get rid of. We click on delete. So you will see over here we had 18 columns and now we have 17. We can check. We can check for the data types, which again look correct to me. This is an integer, and this is a double integer, so the columns that we added. So yeah, that is, I'm happy with the data types. And now we can just take a quick look. Okay, so the data has been loaded, and as you can see that previous start column is no longer here and the other 3 columns are. So finally we just need now sync. We are working with the encounters file, so let's do encounters sync, and we can do the data set processed encounters, which is this one. And yes, so settings, we're gonna again check clear the folder because we might run the pipeline multiple times. Everything else can remain the same, and we can just do a quick data preview, and I think we're good to go for encounters as well. Yes, so this all looks good, and we are done with our encounters. With the transformation of our encounters file, we can click on publish all. A small pause here. Since we are all learning together on this data engineering journey, and I genuinely want this channel to be a place where we can learn from each other. So now that you have seen all the questions that we are trying to answer, and you're also familiar with the 4 files, procedures, encounters, patients, and pairs, what transformations would you apply before we move all of this data into the database? Let me know in the comments. I genuinely want to learn from your approach too. Now let's get back to the video. And now we have the next file, which will be pairs. So pairs, if you remember, was a very small file. Let's take a quick look. So this was the pairs. It just has the ID, the insurance company name, their address, city. So there's not much in here. So all we are trying to do is the pair ID column. We're renaming column ID to pair ID, and I just talked about how you can do that. So I would again recommend to pause the video here. We have also done we have transformed two files. So I would recommend pause the video here and do this on your own. If not, and yeah, you can follow along because I will be doing it. Okay, so let's start. New data flow. We're gonna call it df transform pairs. Okay, we need a source, which is pairs source. We need our data set is going to be ds raw pairs. Let's see. Okay, we have it. All the other options can stay. We can go into projection and import the projection. So this will bring in all the data types of those 6 or 7 columns that we have in the projection, pairs file. Yeah, so they all seem to be string except for zip. Yep, and that makes sense. Let's go into optimize. Yeah, we can leave it as it is. Let's go into data preview, and this will give us this will show us the data that's in the file. It's only very few columns, like 10 rows or something. Yeah, and we can see we have all the data, and yeah, this looks good to me. Now what we are planning to do is rename this ID column to pair ID. So let's do that, and we need the select transformation for it. So rename ID column, right? These options can stay checked. We are not doing auto mapping because we are renaming this column to pair underscore ID, and rest everything can remain the same. We can just see, and we can see we have just changed the column, updated. So you see that this sign over here. Let's go into data preview and click on refresh, and we can see we have the pair ID column, the name, address, and everything as expected. Finally, we just need the sync, so let's do that. Pairs sync. We rename the column, and this will be called ds underscore processed pairs. Yep, everything else we can clear the folder, errors, mapping. Yeah, I think this is all good, and we are done with this file as well. Now the next one, let's quickly look at the data once, just to make sure we have the same 7 columns throughout. Yeah, pair ID, name, address. Yeah, this looks good. We can click on publish all. The next one is the patients file, and again, if you recall, we didn't really have many plans for our patients file. So what we're going to do for this one is, and this will also allow us to learn about more transformation functions on the in Azure Data Factory or Data Flow. So what we're going to do is we're going to mask some of the columns in order to protect confidential data, and we're going to delete the lat and lon columns. So let's look at patients file and try to remember what it was. Let's do a preview. So we had the ID, we had the birth date, the death date, we had their name, then we had their marital status, race, ethnicity, gender. We had their birthplace, address, city, state, county, zip, and then lat and lon. So a lot of these information looks confidential to me. So what we're going to do is we're going to try to mask the data in these columns through the various functions that are available. So that's what we're going to do. So let's get started. Okay, so to transform the patient's file, we're going to again start a new data flow. Let's call it df transform patients. And we're going to start with our source, which is the patient's source, and this will be ds processed, ds raw patients csv. Everything else looks fine. Let's import the projection. Okay, so we have the ID, the birth date, death date, and we have the data types. So this all looks good. Let's click on data preview and see how it looks over here. Okay, so yeah, we can see all these values and they came through. I don't see anything wrong with it. So we have all of this data and we're going to try to mask some of these columns and let's see which ones we plan to do. So let's start with ID. And I want to show you different functions that are available. So for this one, what we're going to do is we're going to use the SHA2 transformation. So let's start with derived column, and we want to do these transformations in place. So I won't be adding new columns and then deleting the original ones. I would just do it in place. So let's see the first one, which we do. Let's do the ID, and let's open the expression builder. So what I want to do with this is so this will just create another ID altogether for the ID column. So let's do that. Let's click on save and finish. Everything else can remain the same. Let's do a data preview refresh. Okay, so now as you can see, we have for the ID column, we have very different value. If you look at the original data set, we have all of these hyphens in between and there's no such thing. So we have completely changed the values for this ID. So we have done that. Let's see what other columns we can change. So what about birth date? So we have birth date. How about we only save its year instead of the entire birth date? So let's do that. Let's see how we can do that. We click on plus, add column. We're going to choose the column as birth date. Let's open the expression builder, and we're going to do year for birth date, and I want to save it as string. So let's enclose it in a string. Let's click on save and finish. Let's go to data preview and let's do a refresh. Let's see how it looks this time. And yeah, so I only have the birth dates or the years for the birth date, so that's good. I could do the same for death date as well, but I'll leave it as an activity for you guys. Next, what we should do, let's look at birthplace. So again, sounds confidential to me. What I don't want everyone to see this entire Wakefield, Massachusetts US, Brooklyn, Massachusetts US. What I just want people be able to see is just the last two characters, which is US. So let's see how we can do that. Let's add another column. The column that we are working this time with is birthplace. Let's open the expression builder And what we're going to do is, so we're going to use the substring function for birthplace. Since we only want the last two, we start from there. We start from the U, and then we only go 2 characters, which is U and S. So we just do that. And what we also want is like to show that there's something before this. So I'm just gonna add or concatenate something like this, which is, so now these are both strings. We can click save and finish, and we can go data preview and click on refresh. Let's see how the birthplace column turns out. And as you can see, so yeah, we only have those last 2 characters, US, CN, IN, I presume that's Indiana. So we only have these, so that looks good. Next is address. So again, I don't want the entire address to stay this way. And once again, like, we're doing all of this because eventually the data will be copied in a SQL database, and a lot of people would have access to that. So we don't want these confidential information to be, like, lying in the database as in an unsecured or unmasked way. So that's what we are trying to do. So let's again go into derived column settings and try to mask the address column as well. Let's add column, which is address this time, and we will only leave the first 3 characters this time. So we're going to use something very similar to what we just did. Substring, the address column, we start from the first, we go until 3, and then we want to tell the end user that there's something after this. So very similar to what we did for the birthplace column. And we're going to preview it towards the end. And then one more thing that we were left with is, let's see. So we also have city, state, and county. Maybe that can stay, but we have the zip code and we don't want the entire zip code to show. So what we're going to do is just show the last 2 digits. And we obviously are planning to delete the lat and non column. So this will really hide at least the residential address of these patients. So let's do that. Let's go into this. Let's add another column for the zip, and what we're gonna do this time is concat. We're gonna type this, and since we only want to keep the last 2, so, and zip is an integer, so we want to first convert it into string, the zip column, and we want to keep the right. Will make sure that we only do the last 2, and yeah, that should do it. Okay, let's go into data preview and click on refresh. Okay, so the address column has also worked as expected. So we only see the first 3 digits of their address, and then there's nothing else that we can see. And the zip as well, we only see the last 2 digits of their zip code, and after that we don't see anything. So yeah, so we were able to mask the columns that we wanted to for the patient file, and now all we need to do is select the columns for our sync. So let's do that. Let's call it select columns for sync. We keep all of the columns except lat and non. We were not deleting any other columns, but if required, or if the business requirement has it, like we need to delete some of these columns, we should do that. Or if they need to be masked any differently, we should do that too. So let's go into inspect. The birth date is string this time, and the death date is still date, which is fine. And yeah, let's go into preview and let's see. So we started off with 20 columns this time, and now we are down to 18, which was the end goal. So yeah, we can see we have the columns and the values are as expected. The lat and lon columns are no longer here, and now we can put this in the sync. So let's do sync. So this is patients file, so patients sync. Let's add the data set, which would be processed patients. Rest everything we can clear the folder. And yeah, so that it looks fine. Okay, so we have the data, and yes, it is as expected. We can click on publish all, and congratulations, so we are done with the transformations, but the files are still not there because we haven't run the pipelines, and that's what we're gonna do next. So now we're gonna run these transformed these data flows as pipelines. So we already created a transform folder, so we already had that. So all we need to do is now create new pipeline. So let's start with procedures. So PL, and we're gonna call it transform. So PL for pipeline, transform procedures. And we're gonna again look for, so under move and transform we have the data flow, so we can just drag it and we can call it transform procedures. And our settings, so yeah, we are using the df transform procedures to run this pipeline. Compute size is small. We are so this logging level is if the pipeline fails, where do we log the logs? So that's the gist of this, or that's what this wants. But since we are not doing this at the moment, so we're just gonna click on none, and all of the other things can just stay as it is. There are no parameters to pass. So yeah, we just click on debug and the pipeline should run. So let's do that. And once this is done, so it will take a few seconds, probably up to a minute or two. Once this is done, we should be able to now, this time, if we go into processed folder, we should be able to see the files showing up over here. So let's close all of these. So now we have the processed, and we should see the files coming up over here. So this is running, 21 seconds have passed. Let's just wait. Okay, so the pipeline successfully did run, and we can see it took about a minute and 22 seconds. It might take a bit longer or slower sometimes. So let's click on the details and see what happened to know more about this pipeline run. And we can see the cluster startup time to run that pipeline was 1 second and 472 millisecond. The number of transformations that were performed were 4. The number of rows that were written was 47,699. So all of this information is there. And now we can also go back and refresh and see. So instead of one CSV file, we have the folder. Let's see what's in the folder. And we have like 3 files. So because again, it might have Azure Data Factory decided on its own how to put which rows in which file, but we can also select that, like, if you want to divide them by some, like, different kind of procedures, or by year or something, which is very common, we could do that. So let's check the file. Let's click on preview. And if you can remember, we only added one column, and rest of them are the same. So you can see the start, the stop, the patient ID, encounter code, and everything else is the same. Just the duration in minutes is something that we added, and that's there. So let's check another file and let's see. So yeah, so everything else is as expected. And we need to run this pipeline for the rest of the 3 data flows as well. And I would recommend just pausing the video here and then doing it on your own. So let's do that. Let's click on new pipeline, which one we'll call it PL transform. Let's do the next one as encounters. If you remember, we have 3 new columns this time. So let's do data flow. Let's give it a meaningful name, transform encounters. Let's call it df transform encounters. We're not doing any logging, and it can remain the same. Let's do debug. And the pipeline has queued, and let's see how long it takes this time. Okay, so it took about 1 minute and 24 seconds this time. Let's check the details. So the cluster startup time was just under 1 second. This time we had 8 transformations, and the number of rows that were written is 27,891. Let's see. Let's go to our Azure Storage Explorer. Let's click on refresh and enter process. Yep, we have the encounters folder, and we have 2 files for the same. Let's close these 2 and let's click on preview for this one. Yeah, so we have the ID, the start, stop, patient, organization, pair, encounter class, code, and then towards the end we have the 3 columns that we added, which is over 24 hours. So if it's 0, then it wasn't. If it's 1, then it was. Days between readmission, then you will again see values, and some places you will see blank as well. So we have these values, and then readmission between 30 days. So 0 means they weren't readmitted within 30 days, and 1 means they were. So we can see 3.0 has 9.0 has 1. So all of these have values as 1. So yeah, and one of those has 0.0, so they were probably readmitted within 24 hours on the same day. So this one has a 0 value. So yeah, and where it's null as well, the readmission is 0. So yeah, we have 0.93, and the value is again 0. So yeah, and for 1.0 as well, since we didn't use less than equals to, we just used greater than, not greater than equals to, so we again have 0. So it is working as we would like it to work. So yeah, so this is also done. Now we need to just create the pipeline for the other 2 transformation files, for the other 2 data flows. So let's do that. New pipeline, PL transform pairs, call it transform pairs. We use the transform pairs file for that, and we can just do a debug. Let's wait for the pipeline to finish. Okay, so This pipeline has successfully run as well. It took about a minute and 25 seconds. Let's look at the details. So the cluster start time was a bit longer this time, 1 second and 4 millisecond. And then we have only 10 rows that were written. So we only had that much data. So let's go ahead and check. Let's go ahead and refresh, and we need to go into the pairs folder, and we only had one file. So we have the pair ID column as we rename that column. We have the name, address, city, and everything as expected. So now we just left with one more transformation pipeline and one more file. So let's do that. New pipeline, PL transform patients. Let's do that. Transform patients. We choose the data flow for patients, and yeah, let's click on debug, and the pipeline is queued, and we'll just wait for it to finish. Okay, so this pipeline has successfully run as well. Let's look at the details. So we did 4 transformations. Mostly it was masking the columns, and then later on we deleted 2 columns, and the number of rows that were written is 974. So that means we have about 974 unique patients across 10 years in our data. I can click on publish all, and while it does that, we can also go and check our patients file and how it has been written. So let's click on refresh. Let's go into the processed folder, and we have patients folder. There's just one file. Makes sense since it's less than 1,000 values. Let's click on preview. We have the ID. The birth date is just the year. The death date is as it is. The prefix first, last. So we didn't make any transformations over here. The birthplace and address has been done. And we can also see the zip, just the last 2 digits. So yeah, so all of these transformations worked as expected, and the files as well came through. So that's great. And now, if you remember, let's take a quick look at our solution architecture once again, just to refresh our memory, since we have been working in ADF for far too long. So let's go back to our solution architecture. Yeah, so we started off with getting the data from HTTP. We ingested the data using Data Factory, and we bought it. We put all of that in this raw folder. So if you remember, all of these raw data sets were that. Then we did the transformations in data flows, and we just ran the pipelines, and now we have all of these in the transformed folder or transformed data sets. So we have them over here in the processed. So now we are 2 steps away. So now we need to do the storage, and then we're going to connect this storage layer to Power BI, and that will be the end of this project. But before we do that, let's again remember that copy activity which I was talking about. So we already created a link service to communicate with our SQL database, but we haven't created the sync data sets for this SQL database. So now we need to create that, as you will be copying data from the processed or this transformed folders or sources to now SQL. So let's do that. Let's create a new folder first. We're going to call it SQL, and we again need 4 data sets. We already have the source, which will be the processed ones, but we need the sync. So we need to create 4 of those data sets. Let's create This time it's SQL DB, it's not something else. So let's give it a meaningful name, DS SQL. Let's start with procedures. Then we already have the linked service and it is identifying since we already created this. The table name. So we haven't created the table. So let's go back. So let's leave it. Let's click on cancel. What we need now is, since it will be stored in the SQL database, we need some tables in there as well. So I have the code for that. So let's do that. Let's go into our resource group. Let's go into the DB hospital patient. So this is our database. We are going to click on this query editor. Again, just like we have this Azure Storage Explorer, there are other tools as well, something like VS Code that you can connect to this database, and they have a better interface and more functions. But I'm not going to use it, so that everyone can follow. So I'm just going to use this query editor. We have the hospital admin, that was the admin name, and we need to put in the password which we created earlier. So let's do that. Okay, so once you put in the password, let's click on OK. Okay, and this is how the query editor looks like. We'll have all of these tables and views. We don't really have any much over here, so that's why you don't see anything. So let's change that. Let's first start with creating our schema. So let's create hospital admissions as our schema, and then within that we will create the 4 tables. So let's click on run. The query was successful. So let's create procedures table, and I will leave this file as well on my GitHub, which you can access from the description. So let's do the we need to select the proper data type as well. So start and stop are date time. The patient is character of 36 and counter is character of 36. The code via chat, so things like that. So we need to make sure that we are selecting all of these things properly. So let's do that. Let's click on run. Okay, so this is successfully run as well. And similarly, let's just create the other 3 tables as well, and then we'll just create, and then we'll just run this. So let's just select the 3 tables, which is encounters, patients, and payers. Let's click run, and it's successfully run, and we can select so there is no data, so let's click on refresh. But when we click on this, so we can see encounters, patients, payers, and procedures, and it will also show us all the columns. So which one is a primary key and not null, so everything is in there. So this is good. And now we need to head back to our data factory, and we can also turn this off debug now. Since we are no longer debugging, all we need to do is now copy this processed to SQL. So that's all we need to do, and this will save you some money. So let's turn this off now. Okay, once this is done, I would again like to first create a new folder so that we can put the SQL pipelines in there. So we'll call it SQL. Let's create, and we're going to create new pipeline, and we're going to call it PL. So we are just copying it to SQL. So let's do procedures first, and we're going to do copy data. Let's say copy procedures to SQL. The source this time is going to be our processed procedures. So procedures, and if you remember, this was a folder, this was not a file, so we're gonna have to do wildcard file path and then put a star over here, which it automatically comes. So in processed folder we have the procedures, and then we select all the files that's in there. So this is good. Sync, we need the okay, so yeah, we didn't create the sync because we waited for the tables to be created. Okay, so now we can create the sync first. Okay, my bad. So let's create new data set, which we stopped the last time. So SQL DB. Let's continue. We call it DS SQL procedures. Already have this. Now the table name should appear, which is procedures. Import schema. Yeah, we can do this time. Click OK. Yeah, and everything looks fine to me. So we'll create the other three as well, but let's just try running this pipeline, see if it works. DS SQL procedures. We need to insert table option, use existing. So all of these other things, mapping, settings, yeah, they all look fine. Let's click on debug and see. So we'll just wait for the pipeline to run. Okay, so the pipeline has successfully run in 40 seconds. Let's look at the details. And you can see the data was read 8.834, it's written 13.615. The rows was so all the rows 47,699 have been written, so it was successful. So let's see, let's go back to over here and let's try to see. Let's do a new query. Maybe we can do select star from, let's see what this looks like. So we just did procedures, and let's run this query. And yeah, so start, stop, patient, encounter, code, description, everything is in there. And you will also notice that those T and those is back. That's because we chose the as date time, and that is the standard way how we should be doing it. So we changed it from timestamp to date time, and once we import it into Power BI, you will see that the Power BI automatically recognizes it as year, month, and date, and then hours, minutes, and seconds, and it will be look all clean in there. So just have patience and we'll see. So now what we need to do is go back over here. Let's create our 3 data sets first, and then the 3 pipelines. And once again, I would recommend pausing the video here and doing it on your own. And if you get stuck, come back. Okay, let's do it. New data set, SQL, DS SQL, we'll do encounters. We know the link service, the table is already created, which is this one. We can import the schema, click OK. Okay, let's create the next data set, which would be SQL DB, DS SQL, which is pairs. Let's select our table as pairs, connection store, yeah, click OK. Okay, and finally let's create our last data set, which is DS SQL patients. linked service, and we can do patients, connection store, click OK, and these look good. Now we need to create our pipelines, so let's do that. Let's create a new pipeline. So PL SQL encounters. We just need to copy the data, copy encounters to SQL. The source would be the processed encounter, and the so all the files in there. So we choose the wildcard file path, and the sink would be the SQL encounters, and everything else can remain the same. So one more thing that I would like to add, like if you had data in which was like a complete refresh, like it every single day, so you would probably want to add something like truncate table encounters. But since that's not is what is happening, we might have more newer data instead of all of the data, so we don't need to do that. But this is also what you can do, like add a script which should run before this pipeline runs. So that's what this option is there for. So yeah, let's do a debug, and while it's doing it, let's just wait. Okay, so the pipeline has successfully run, took about 44 seconds. Let's look at the details, and yeah, 27,891, and all of those rows were successfully written. So let's go back and check. So this time it is encounters. So let's make sure that all of the data is there. Yeah, so we have the encounter ID, the start, stop, patient ID, organization, the pair, the insurance, encounter class, and yeah, the 3 columns that we added: over 24 hours, days between readmission and readmission, 30 days. Yeah, all of the data is there. So this looks good too. Now let's go back to our data factory and create the remaining 2 pipelines. So a new pipeline, PL SQL pairs, and we can just copy the data, copy pairs to SQL. The source would be the processed of pairs file, which is this one, and the sink would be the SQL pairs. Yeah, everything else looks good. Let's just run this pipeline. Okay, so the pipeline has successfully run. It took only 14 seconds, and all 10 rows have been successfully written. So okay, let's go and check in our database as well. This is pairs, run, and yeah, pair ID, the column name that we changed, that came through, and it looks good. Okay, we are just left with one more pipeline. Let's do that. PL SQL patients. Copy patients to SQL, and our source would be the processed patients, and our sink will be the SQL patients, dataset SQL patients. Everything else can stay as it is. Let's click on debug. And let's just wait for the pipeline to finish. Okay, so patient's file has been successfully copied as well to SQL database. Let's look at the details. All 974 rows were read and successfully written. So we can go and check in our database, and meanwhile we can click on publish all over here so that this can happen. So now, yeah, let's go ahead and check the patient's file. Let's click on run. We have the ID, birth date, death date, everything as expected. Some of the masked columns, let's look at that. Yep, the birthplace, address, and then the zip. So yeah, it all worked as we would have wanted it to. And if we quickly again look at our solution architecture, we will see that we have now as well copied it to the SQL database. Now there's one more step, which is connecting this SQL database to Power BI and creating our report. So I won't be going into creating the report for Power BI. I'll just give you how to get started, and we'll try to create one or two quick visuals. But since it's outside the scope of this project, I will again leave this as an activity that you guys can do, and guys can explore all of the data. Excuse me, all of the reports, or maybe try answering all of the questions that we had. So these ones, so you can try that. So okay, let's first go to the so yeah, so you can start with downloading Power BI desktop. You can just Google it, and the first link should give you that. It's not available as a download on Mac, it's only on Windows. So if you're on Mac, you would need something like VMware or something, so that you can run Windows on it, and you can just download the file. So I have it downloaded, and this is what the interface is going to look like. So let's click on blank report. So for this one, what we have is, this is your canvas where all your visuals you will make. These are all the visuals that are available for you. Over here the data appears. We don't have any data at the moment, but we'll import very soon. And then on the top we have all of these options, like to get data, to do the transformations in Power Query. So like the transformations we were doing in this data factory, you could also do some over here. Over here you will be able to see all of your data that you've imported, and this is the data modeling view that you can do. So let's do that. Let's bring in the data first, but before that we need to see, let's go back to our data factory, or rather I should go to the, yeah, we can unsave. Let's go to our database. No, so this is the server name that we will be connecting. So we need this, and let's go into Power BI. Let's go into get data, more, and let's go into Azure. So we are connecting Azure SQL Database. So let's select that. And we have the server name already, which is this one. So let's do that. The database is optional. We're going to use the import mode. So let's click OK. It's going to ask us, since we have that credentials that we created, the hospital admin one, so we would need to input that. Let's input our credentials, the username and the password. Once you have put in your username and password, you will see the database that we had created, and there are 4 of these files or tables in there. So let's import all 4. Let's click on load, and it will take a few seconds to import all of the 4 files, although there's not a lot of data in there, but it's just going to take a few minutes. So let's just wait. Okay, so the import is complete. The next step is, as I was telling you, you can see, so these are the encounters data. You can see it's all over here. This is the patients. You can also see how many rows at the bottom we have. And in this one this is the data modeling view. And if you know, Power BI works best with the star schema. So what we're going to do is connect these, make these relationships. So you will see the hospital admissions pairs is already connected to encounters in a one-to-many relationship. So if we click on this, you will see that the pair ID and pair are already connected. We can also connect the procedures one. So if you remember, one encounter would have many procedures. So we can do that, which is, so let's find encounter ID, which is this one, and over here as well, that's the encounter. So let's make a connection, and this will be one to many. So let's click on save. So we can do that. We could also do the patients via their ID to procedures and encounters, but we won't be able to since we masked that data. But if we wouldn't have, then we would have been able to do that, and that's okay. So like for this example, we don't really need to, so this is good enough. So let's go back. Let's try to answer like one or two questions that we had in there. So let's see how many total encounters occurred each year. So we probably want to look at the encounters file, which is this one. Let's use this chart. So start, and then we can look at the year. That's what we are trying to go for. And how many encounters. So we have the ID and we want basically the count. So yeah, we have the count. So these are the number of encounters that occurred each year. So in 2011 it was 1336. In 2014 there was like 385. In 2021 3530. So these are the number of encounters that happened each year. Let's see what else we can do. For each year, what percentage of all encounters belong to each encounter class? Now, in order to calculate the percentage, you would need some DAX measures, and that's outside the scope of this project. So what we're going to just do is add the encounter class as a legend, and we would have the numbers. We can probably go and turn the data labels on. So yeah, we can see these many encounters each year and what class they belong to. So ambulatory is the maximum each year, as you can see, and then the orange ones, which is inpatient, looks the least, followed by wellness. Yeah, they also are not that many. So, and we can obviously calculate these as percentages. We just need to write some DAX, and that can be done. There was another one, which is what percentage of encounters. So since we created this column, let's test this out as well. What over 24 hours, under 24. So let's do this, so you will see 0 means majority of these were under 24 hours and very few were over 24 hours. So yeah, and now if we go back to our solution architecture, you will see that we have finished this from getting the data from GitHub, ingesting all of those files via Data Factory, and once we did that, we stored the raw data in the ADLS Gen 2. Then we did some transformations using data flows for all the 4 files, and then ran that through 4 different pipelines, and then stored it in a transform data layer. We finally copied this data to a SQL DB, and now we have created these dashboards in Power BI, or these visuals in Power BI, to answer the business questions that we initially had. And that was an end-to-end data engineering project, and that's what we set out to accomplish at the beginning. So congratulations if you followed this until the end, and thank you. And that brings us to the end of this project video. We now have a reliable workflow that tracks admissions, readmission patterns, and key patient metrics. This is the kind of pipeline that hospitals rely on to manage patient care and their operations. The slides used in this video, the SQL script to generate the table, and the data all is available on GitHub. The link is in the description. I hope this video helped you understand how real data engineering works. Thanks for watching.